Now I'm going to tell you about another omega sequence puzzle, which I think is hard. And this one, too, was designed by an MIT professor called James Thomson. And it's referred to as the Thomson lamp. Lamp. So this is meant to be a desk lamp. And I don't even know if they make these anymore, but apparently he had one that had a button. And then if you say it's off, if you push the button once, it goes on. And if you push that same button again, it goes off, and then on and off and so forth. So what we're going to do is we're going to create an omega sequence. So say that at noon, our lamp is off. And then at 11:30, we're going to press the button with the result that the lamp is going to be on. And then at 11:45, we press again. So the lamp is going to be off. And then at 11:50, I don't even know what it is. 15 divided by 750, 52, 30 seconds. I press again, and then the lamp is on, and I keep going. Oh, sorry, I did 11. OK. Say we just started at 11. So here is the question for you guys. At noon, is the lamp on or off?
I'd say it's really an indeterminate state because you're basically asking what's the last number in an infinite sequence of alternating ones and zeros, and there is no last number in that sequence.
I think that that's exactly right. And again, I think that that is an agreed upon solution to this puzzle. So let me just expand on what you said. The description of the case gives us perfect information about what's going to go on with the lamp at all points prior to noon. So if you give me any time between 11 and noon, not including noon, then the facts of the case tell you exactly whether the lamp is going to be off or on. But nothing in the case tells you anything about what happens at noon. In fact, you can think of it as a function which has a discontinuity point. So you have 11, noon, and you go from off to on, to off, to on, to off, to on. And then the function just tells you nothing about what happens at noon. Now, one thing that's weird about the case is that there's no way of completing it without a discontinuity. So there's like no natural stable way of continuing the sequence. But that doesn't mean that the setup of the case is inconsistent. I mean, maybe it's inconsistent if you add in certain laws. Say if you have like a very minimal physics that just guarantees that natural phenomena are going to be continuous in some broad sense, then you can't construct a Thomson lamp. But it really is consistent. One way of seeing that it's consistent is to imagine this. Imagine that you have a version of the lamp such that each time you push the button, it's not just true that it changes from on to off or off to on. It's also true that it reduces its size to half. So suppose that at the initial state, the lamp is 1 meter tall. And then at this point, it's 1/2 meter tall, and then 1/4, and 1/8, and so forth. So that series converges to 0. So you could just think that what happens at the end is that there's no lamp. The lamp has disappeared. So that's an example of a case in which it's not off, it's not on. It's rather that it's disappeared. There's no more lamp.